מדי, אז בואו נתחיל. הפרויקט שלי, it's called Trace View History. Chapter 1, the what. When I started working on my final project, people started asking me, what's your project? What are you planning to do? My reply was, I want to visualize the legend of a Wikipedia article online. Most people, after I would give them this answer, this is the look I would get, kind of like, what? And then I would start to try to explain that I want to see how people take initiative without a manager telling them what to do. For example, this guy here. Stigmergy, there's a word for this, it's called stigmergy, and this is when the work of one stimulates the work of another. We'll get there. Be strong. Ants do it. This is how they find food. Basically, this is how ants find food. Basically, let's say one ant leaves the nest, starts randomly look for food, finds food. When they find food, they start emitting a pheromone, kind of like a scent. And on the way back to the nest, they basically create a trail that other ants, when they leave the nest, can follow to find the food. This is also how termites build their nests. Basically, one termite comes, makes a pile of mud, another termite comes, and instead of creating a pile of mud next to the pile of mud, they add mud to this existing pile, and slowly they create these complex nests that house nurseries, agriculture, and my favorite little detail is they build a chimney that filters air within the nest, and they have the ability to control the temperature within 2 degrees. So this is really a very impressive accomplishment for little tiny termites. Basically, the what is generally understood, and the how is spontaneously improvised. Things get done without a boss. So what? Why do we need it? Chapter 2, the why. Basically, today the world is becoming a lot more complex. Across all industries, we are experiencing serious complex problems in governance, in sustainability, and in growth. And we see this everywhere. We see this in agriculture, in urban development, in markets, finance, technology, healthcare, policy, anywhere that there are big organizations of people trying to accomplish big things. We're running into a lot of problems with complexity. And what's holding us back from finding these solutions? One thing that's holding us back, one very major thing that's holding us back is hierarchy. The complexity you can handle, this is a big one. The complexity you can handle depends on how complex a system you are. Which means basically the hierarchy cannot handle complexity because hierarchy is not complex. As we know, it's very simple, it's very linear. In the most basic form, one is on top, delegated to management, all the way down. It's very predictable. When hierarchy cannot cope with complexity, you get bottlenecks, you get rising costs, lags and delays, and corruption. I mean, these are problems that we're all familiar with in all these types of industries. One of the big reasons why hierarchy can't cope with this complexity is that there's only so much a manager at the top can know or can understand. And there are only so many hours in a day for one person to know and understand everything for everyone and gain control and management over an entire organization. To solve complex problems, we must discover alternatives to top-down design. We need to organize bottom-up. We need stigmergy. Ants can do it, and termites can do it. The question is, can humans do it? Humans, they're not so good at it. In the most simplest terms, when there's messages in the environment like something needs to be done, humans, they don't react very well to indications in the environment. The actions of one with humans do not necessarily trigger the work of another. I don't know how many times you guys leave maybe dishes in the sink because you don't have time to clear them. your kid isn't going to come and say, oh, I need to maybe put this in the dishwasher or take care of this. It's probably going to stay there until you get back. Little is known about human stigmergy, but there are places where it does happen. Check with the environment. The environment chosen for this project is Wikipedia. It's a free encyclopedia online. In the simplest terms, Wikipedia is awesome. It has 30 million articles in 287 languages. It's current, sometimes even more current than news agencies. It's credible, it's non-profit, and it's completely free. Wikipedia is bottom-up, it's volunteer-initiated, and it's created by user-generated content. No boss. All this is possible through human stigmergy. So let me just we have the data. All we have to do is view history. This is the problem. It's very difficult to handle this kind of information. Between items and the law of continuity, we make certain assumptions based on how things are organized. And we can use adaptive soup to investigate, in this case, macro analysis, which helps us identify patterns, relationship analysis, this is kind of zooming in a little bit closer, which lets us see connectivity, and the final zoom in is the microanalysis, which lets us basically understand a little bit more about the individuals who are participating in the collaboration. So for right now, I'd like to introduce Trace. Trace is a new tool for visualizing human stigmergy in Wikipedia. Trace gives form to the otherwise invisible collaborative process that happens every day. With Trace, you can literally view history. So again, if we want to jump back to our paperclip example, where our history looks like this, what if it looked like this? This is the history of, this is Wikipedia history of paperclip. challenging to see, but in fact, it makes it even more prominent where there are certain activities happening that are significant in the history of the article, and maybe where there are less significant. This is our timeline here. The length of the article, as you can see, is growing over time. And just by the basics that we decided where additional text is yellow, deletion of text is white, we can immediately see this and automatically know this is an incident where somebody added an exaggerated amount of text and somebody deleted it and brought the article back to its, I guess, standard length at the time. Trace makes it possible to start asking questions. It is especially interesting in the context of conflict resolution. Trace can show how a collaborative environment handles highly disputed topics, like one near and dear to our hearts. These are 6 maps. We have of the Wikipedia page Israel, Palestine, Israeli-Palestinian conflict, Israeli-occupied territories, Gaza Strip, and Jerusalem. We can ask, how is conflict handled in a collaborative environment? It lets us see what is in agreement, what is in dispute. Another interesting context we can explore is the study of knowledge. Through its popularity, Wikipedia has become a powerful platform in defining knowledge and history. However, it is important to note that the terms and the respective history are representations of truth, rather than an ultimate and unquestionable truth. For example, this is an issue that's happening right now. It's being recorded in Wikipedia. The argument of whether there were chemical weapons, there weren't chemical weapons, who was using these chemical weapons. Ultimately, whatever is written in Wikipedia, think about 20 years down the line, 30 years down the line, that's what will be accepted as history, as fact. We can ask, what is the discourse that builds this fact? Who is involved and who is excluded? How are things being perceived and how are they being remembered? One last example is the topic of global brain. Collective intelligence distributed across the globe may also be referred to as global brain. Basically, the idea is that the internet is being used as a nervous system for the earth, where thoughts and ideas are contributed by the individual, and knowledge is perpetually generated and openly shared with the collective. With Trace, we can ask, how can we manage communication and interaction in such a context? This is one of the major questions that we have in researching global brain. The point is that by creating visual maps, Trace makes it possible to start asking questions. Right now, I'd like to present to you some patterns that I've identified through my work. These are presented as hypothesis patterns. They still need to be researched. They still need to be validated. But it definitely makes a case for how, when you see something, you can start correlating patterns with human behavior. The first example I'm going to show you here, this is the Wikipedia page for Defense of Marriage Act. This is basically speaks of the right for gay people to get married. And when you look at the map, you want to see kind of where interesting points. And one of the very bright points on the map is on June 26, 2013, DOMA was deemed as unconstitutional. So at this time, the reason that this is so bright is that there's many, many changes being done at a very specific point in time. So this is a significant event. Another pattern is the pattern of, I call it terminal vandalism. This is an example when people delete, just go in, edit, and delete the entire page of the article. It's at the 0 point of the page length. And again, it's very easy to see how much vandalism is being experienced within a certain page. Another pattern, it's called a stable drop. What happens is an article is growing over time, all of a sudden it experiences a drop. Now, previously, remember when we saw the paperclip article, it was a huge jump, and then the text was brought down, the length of the article was brought back to kind of the same median place. In this case, it's pushed down, and then it continues here. This basically new paradigm basically means that there was enough text within the article to create an entirely new article, in this case, History of Palestine. What's interesting about this is really stigmergy in the context of an entire article, where one article creates another article. Another pattern I want to show you, I'm calling it organic turbulence. Turbulence is like when you're on the plane and it starts shaking and moving and buckle your seatbelt and right? The idea is that Wikipedia is supposed to reflect human collaboration, human interaction. Yeah, that's fine. So what you see here is something that's very indicative of a back and forth. This is like a conversation happening between many different people. You can compare this to something like another pattern. This is rigid growth, where you see that basically the growth of the article reaches like a mathematical precision. It's growing in a way that's very, very exact. And so let's say unlike this area here, you can start asking questions of why is it being so exact? Is there interference, a hierarchic interference within the process? An important thing to note about Wikipedia is that there is a hierarchy within the system. It isn't entirely open and no hierarchies involved. Certain people are limited into how many and to what changes they can make. And there's also technical bots that interfere in the text and make changes. So when you visualize the map, you can start maybe identifying certain areas where there's interference and certain areas where there aren't. Another thing that you can look for is you can compare maps and start looking for correlations between certain pages. I mean, this is kind of almost an identical shape in these two articles, whereas other articles didn't have it, and you can start asking why. By use of an interactive map, it is possible to start asking meaningful and site-specific questions relating to collaboration, stigmergy, knowledge, and more. We can also investigate significance relating to hierarchy and stigmergy, and the balance between the two of them, meaning how much of hierarchy is necessary so that human stigmergy can happen, and how much of it needs to be basically controlled so that stigmergy can flourish. We can also explore classifying author types, people who contribute a lot, people who encourage other people to write, and the same thing for articles. The last chapter is basically a demonstration. The project is right here. During the break, everybody's invited, if they're interested, to come use the tool. What you can do basically is the tool shows you 6 maps. You can select one of the maps. Let's pick Israel. And with the mouse, you have certain things that you can do. First of all, you can scroll over the ellipses to see the name of the author, the time the change was made, as well as any comments that are added. You can also zoom in to investigate. Oops, yeah, the mouse here is a little bit sensitive. You can also zoom in to investigate, for this example, let's say the vandalism where people were deleting up until 0. You can easily refresh the map and bring it back to an original. And the last thing I want to show you is you can play the article over time, the collaboration over time. And when you do that, this basically lets you see in a more clear way, when does it slow down? When it slows down, it basically means people are interacting with each other, making changes at a very specific point in time. And when the article speeds up, which is basically there's a certain type of consensus, the article is flowing along, people are in agreement, and it's growing, and it's growing naturally. So if we want it, we can also, we can also fast forward it. We can rewind it. And the last and final thing is we can pick a specific point. Hold on, let's jump to the end here. We can pick a specific point on the map. Let's say this point here. And then we could start researching contribution by contribution to see how the interaction is between people. So this is my project trace, And I want to thank Arifan, my advisor. I'd also like to thank the help that I received from the Xulon Interactive Lab, from Shachar, Giga, and Zvika Maxfeld. And that's it. Thank you very much.